We talked about the reactions and what was important. Remember, write these last three about 4 times, 5 times, whatever. Make sure you know them, please. Please make sure you know these last three, okay? When you have this thing with the bromine and you want to convert it, group 7, and you want to convert it to an alcohol, and when you want to make phenol, okay? So I should put this here. When you want to make phenol, okay, either from this is an amine, and here we have it from something with the group 7, okay? Remember that this amine, we call it aniline, okay? Do not forget that. So what did we put here? You can see Na, NO2, and HCl, and then you put water. So remember, write it 10 times. I don't know how many times. Now let's do, okay, so there's a reaction mechanism on this hydration reaction. We'll come back to it and we'll see. Now, what about the reactions of alcohols themselves? Well, the reactions of alcohols themselves are not hard. The first thing you should know is just dehydration, right? You should know that alcohols go through dehydration. This is going to be important. I'm going to show you some things that you should know. And when you do, dehydration means that the alcohol is going to lose the OH and an H and then go back to become an alkene. So here we can have whatever type of alcohol you have. They can try to make it hard for you, you know what I mean, by doing something like this. Let's try. Let's see. Put my OH here. Then this guy, I'll put a carbon again here. Then we have something like this. Okay, so now what are we going to do? We want to make, you'll see if we put, dehydration is very simple because when we made an alcohol, we just had an alkene and we added water and an acid and we didn't do nothing. But this time you are just going to heat. You add an acid and you just heat, okay? You just heat. Then it should go back. It should do the dehydration. So what happens is this OH goes, right? So anyway, we'll be having it as a, and here's something very important which I want you to know. It's like if I have this, I'm going to say, let's say we have something like this. This one has a carbon and a hydrogen like this. All right, so we have it like this. All right, we have it like this. Now the question is, this is the OH, right? We want to know, am I going to get H from this carbon or from this one? I have 2 neighboring carbons. I have this carbon and I have this one. Where will I get the H from? Where will I get the H from in this situation? And in this one, it's like a weird way. It says, I'm going to take the H from the carbon with more carbons to him. So this carbon has more carbons to him, so I'll take an H, not this carbon with more hydrogen, which is weird, but it is what it is. So that is what you do, okay? You draw the structure, but here there will be no hydrogen, and here there is no AH, and you do the double bond. So that's just what happens. This is the dehydration, okay? And then now dehydration is easy. Sometimes they'll give you an easier one, right? Something like this, okay? Where the OH is at the last carbon. So obviously you know that this carbon, which had the OH, and this one are the ones that would then have the double bond. So if they just put H2SO4 and they put 180 degrees Celsius, okay, that's the heat. 180, in here it's exactly 180 degrees Celsius. So what would I then do? Of course, I remove this OH. I had 3 carbons, 1, 2, 3 carbons. So I'm going to make sure I have 3 carbons, which is 1, 2, and 3, then my double bond. So this is what happens, and you'd be done. So this is for it. Now I should go to the second thing. Okay, this here we've seen the dehydration, which is not related to Markovnikov. It's a standalone. Now on this one, what am I now doing? We want to know about halogenation. Okay, when you want to add, we've seen how to. We saw how to work with something that had a halogen. We know that we added NaOH for us to get the alcohol. Now, what about if we want to add a halogen to an alcohol, no longer to make an alcohol from something like that? No, but we want to add a halogen to an alcohol. Then what are we going to do? We use 3 things, which is going to be HBr. Okay, so it's going to be HBr. Then you're going to have SOCl2. Then you're going to have like a PCl3 or PBr3, okay, which are the guys that from group 7. Can you see that? So it's either HBr. HBr can also be HCl, okay? Then we have SOCl2, then we have this, then we have this. Okay, so now what happens and when do I use each? Because we want to work with alcohols now. We want to add a group 7. We want to add group 7. So we can use HBr or HCl. When do we use HBr or HCl? We use it for, so this is going to be used for tertiary alcohols, okay? this is going to be used for tertiary alcohols. Now, this is going to be used for tertiary. Yes, it's going to be used when you have tertiary alcohols and you want to add. Now, you must also know that this same guy is added to alkenes. Remember, to be able to get your group 7. Remember, for alkene, either I can have something like this, you know. Like this. We can have an alkene like this. If you add HCl, then what happens is it now does this, and this is a Cl, and here you'll be having your H, so it's going to be like that, kind of like that, okay? And there's a carbon here, because there was a carbon. If I go back to show you, there was a carbon here, because it was a double bond. So this carbon will go on its own way, and it's the one which you show like this. Then the other one is going to be Cl. So this is what happens. We can add our HCl to an alkene, which is not what we want. We want to see what happens when we add it to an alcohol. Now, which type of alcohol? We say it for tertiary alcohols. SOCl2 and these are for primary and secondary alcohols. That's the first thing, right? But we have to keep going, okay? We have to keep going because same time, you must also be sure you know that. And the simple thing for you to do with this one is you just have to remember that the OH goes and the group 7 comes. So if I add this for a tertiary alcohol, okay, this works for tertiary alcohols, but we may also use it for primary and secondary alcohols. But there is one situation where it definitely doesn't work. The HBr and OHCl, it is for phenols. Phenols, yes, phenols, you'll be finding that you'll be having secondary, the carbon connected to the OH is connected to 2 others. So it'll be nice and it's like this. So for your cyclic alcohols, when you have your cyclic alcohols and whatever, even phenol, then you're not going to be able to use this HBr. It is not going to do it, but you're going to have SOCl2 and PCl3 working. So if I have, let's just see how each of them work. The thing of it is, I'm going to put stars. The things that I'm putting stars for are reactions that you must know mechanisms of, okay? There's going to be, for alcohols, these 3. We'll come back to it. But basically, if I have an alcohol, whatever the alcohol is going to be, you can put your alcohol, right? CH3CH2OH. Now, when I have something like this, if I come and add HBr, then what's simply going to happen is you're going to have the OH going to the beer. So you're going to have CH3CH2, and then you now have Br. Then you say plus, we now have OH coming to meet the H, and it becomes H2O. Okay, that's what happens. Alcohol readily agrees to meet with this, but especially the tertiary one. So let me say C like this. So let's have a CH, then CH3, then CH3. Then we have it like this. Okay, we can use this for our tertiary alcohols. Now for secondary alcohols, remember we love to use SOCl2 and P something, okay, with the group 7. So it's SO, then the group 7, so it's SOCl2, then PCl3 or PBr3. When do I use SOCl2? SOCl2 is called thionyl chloride. And then PBr3 is like phosphorus tribromide. PCl3 is phosphorus trichloride. So these are the things. Now, what are we going to have? Now, basically, what you must remember is that if I have an alcohol, a basic one, like, let me just do it like this. If you have, this is going to be OH. If I come and I now add PBr3, then I'm just going to go straight to have something like this. Instead of NH, we have a Br. Okay? This was PBr3. So it's PBr3. Now, what we normally like to do is to put three molecules of this, and then we end up having 3 molecules of that. And then what would happen? Here we had PBr3, right? Exactly. So we have 3 of them all gone. Okay? Then what we end up having at the end is going to be a H3PO3. Now, that's what happens. You use 3 moles of H when you use this PBr3, okay? And remember to put the H3PO3 at the end. Then now what are we going to have now? Now what do we have? Now we do for the last one, which is SOCl2. For SOCl2, remember that you'll be having something, whatever, we don't care. This is an alcohol. Then if I add SOCl2, then what am I going to end up getting? Well, what you're just going to end up having is, again, the very same thing, chlorine. Okay, but what you should know is that you are also going to then have byproducts of HCO and byproducts of SO2 all the time. So this is what's going to happen. Remember that. You should always remember that. Okay, if you add, now when do I use it? I'm going to use this third method when I'm dealing with alcohols with high MP and boiling point. If you have an alcohol with a high melting point and a high boiling point, okay, then you're going to have this SOCl2. That's the time we're going to use it. But both of them and this PBr3 or PCl3, they work for the very same conditions. They work in the very same conditions, and that is what you're going to have. So here we have the halogenation, and now it's done, okay? Now remember that these are the guys that can go through the cyclic things and work, these two, SOCl2 and PBr3, okay? Remember that. So remember, never put, it's still all three are for halogenation, but this one, yes, it's for tertiary and for some, you can see us use it for alcohols, but never a cyclic one. Never use HBr, HCl on a cyclic one. You use SOCl or PCl3, okay? So what we are going to, and remember that SOCl releases SO2 and HCl also, okay? And this one, remember that it releases H3PO3 also, okay? All right, now what are we going to have? Let's put a cyclic one now, just as an example. Something like this. Okay, something like this. Or we could even have something like this. Let's put it as a phenol. Okay, we can put this as your benzene. Then here, even if there's nothing, you can use SOCl2. You can use PBr3. You can use, remember when you use SOCl2, remember to write at the bottom to say pyridine, okay? You thionyl chloride, and that is, you can use them. But you can't use HCl or HBr, they won't work, but they will work for tertiary alcohols, okay? And some secondary part, as long as they're in a straight chain. So in here, you should add SOCl2 or PBr3, and then you're going to be able to get your results, okay? Don't forget that. So if I come and I say PBr3 here, then I know what's going to happen. And remember to put 3 moles. We love to put 3 moles, don't we? Yeah, we love to. You put 3 only here, and what you're going to get, you put 3 moles again, then you say plus H3, PO3. That's what happens. So here you say whatever. See? So this is going to be what? You can add SOCl2. And what are you going to get? Well, remember just to remove the OH and put the thing. So in here, of course, we know what's going to happen. The OH goes, and here we'll put our Br. Here the OH goes and you put your chlorine, whatever, and then you get your solution. But remember that at the end, after you put the thing with your chlorine, remember to then say plus SO2 plus HCl. And you'll be done. And this is how wonderful it is. This is how good it is, okay? Is it hard? No, it's not hard. Now, these are the reactions. We've done the reactions now. But there's just a little bit more you must know about reactions, just a few more reactions. But some of this is a lot, and it's enough to answer a lot of the questions which you get for your papers, okay? But now, although I still want to show you, there is esterification, which we know. For esterification, if I can... we can put for our reactions, we still have for reactions, we still have esterification, okay? Esterification, we still have it as one of the things.